Okay, good morning, engineers. Our subject is thermodynamics 1. Okay, thermodynamics 2 rather. So we will review your thermodynamics 1. What is thermodynamics? Thermodynamics is a branch of physical sciences that treats various phenomena of energy and the related properties of matter, especially of the laws of transformation of heat into other forms of energy and vice versa. Okay. So from heat to energy, okay, it's thermodynamics. So of course, we say thermodynamics, it also involves temperature. So what is temperature? Temperature is an indication or degree of hotness and coldness, and therefore a measure of intensity of heat. Okay. So there are 6 temperature scales. We have Celsius or the centigrade. We have Fahrenheit, degree Fahrenheit, then Kelvin, then Rankine, and Reaumur and Legend. Okay? This is just a review. So in temperature, we have absolute temperature is the temperature measured from absolute zero. Okay, absolute temperature from absolute zero. Whereas absolute zero is the temperature at which molecules stop moving. Okay, molecules stop moving. This is absolute zero. Then we have relation between temperature scales. We have from degree Fahrenheit. Uh, if your given is degree Celsius, we have then convert to degree Fahrenheit. The formula is 9/5 times your degree centigrade or Celsius plus 32. Whereas from Fahrenheit to degree Celsius, we have 5/9 quantity. Okay, quantity open parenthesis minus F, your degree Fahrenheit minus 32, close parenthesis. Okay, and from Fahrenheit to Rankine, usually this is we use in English. So degree Fahrenheit plus 460. Then to degree Celsius to Kelvin, we have degree Celsius plus 273. Whereas R is Rankine, absolutely temperature scale English units. Kelvin is absolute temperature scale in System Internationale units, ISI units. We have temperature interval is the difference between two temperature readings from the same scale and the change in temperature through which the body is heated. Okay, the formula for temperature interval or change is if it is change in temperature that in Kelvin, that is equal to change in temperature in degree Celsius. Whereas also change in temperature in Rankine is equal to change in temperature to Fahrenheit. So ito, change in degree, change temperature in centigrade is, the formula is 5/9 times change temperature in Fahrenheit. Pag Fahrenheit naman, change in temperature in Fahrenheit, 9/5 times change in temperature in degree Celsius. Okay. Pag Reaumur naman, we have 1 degree Reaumur is equal to 4/5 degree Celsius or 20 degree Legion. Okay. Note, 1 Celsius degree is equal to 9/5 Fahrenheit degree. And degree is to be written after the scale to indicate that it is the temperature change. Okay? So, after. Iba yung Celsius, degree Celsius at saka Celsius degree. Pag after, that is temperature change. We have pressure. Okay? Also, thermodynamics involves pressure. Okay? So, pressure is hindi yan sa tao. Okay? Sa subject lang yung pressure na yan. Okay? Dito lang yan sa thermodynamics. Yeah. Absolute pressure is the true pressure measured above a perfect vacuum. Okay? When we say vacuum, wala nang pumapasok doon hangin. Okay? We have gauge pressure. Is the pressure rather measured from the level of atmospheric pressure by most pressure recording instrument like pressure gauge and open-ended manometer. When we say atmospheric, yung open siya, okay, from atmosphere. Atmospheric pressure is the pressure obtained from barometric reading. Okay? So we have here formula for absolute pressure is equal to your gauge pressure plus the atmospheric pressure. Whereas the atmospheric pressure is equal to 101.325 kPa or 14.7 psi or 1.0332 kg per centimeter squared, or pag in inches 29.92 inches mercury or 760 millimeter mercury is equal to 760 torr, okay, or 1.013 bar or 1.013 times 10 to the 6 dyne over centimeter squared or 760 torr, 1 at 180 m or 0 kPa-G or 0 psi-G. Okay, P abs is equal to, that is absolute pressure, P gauge is the gauge pressure. Note that gauge pressure is equal to negative when the pressure is vacuum. The pressure in perfect vacuum is negative 101.325 kilopascal or kPa. Then we have thermodynamic system and surroundings. We have, what is system? System is the term given to the collection of matter under consideration, enclosed within a boundary. Surrounding is the region outside the boundary or the space, and matter external to a system. Closed system is a system in which there is no transfer of matter across the boundary. Okay? Then open system is a system in which there is a flow of matter through the boundary. Okay? Open system, it's rin open. Yung closed naman, closed talaga. So walang naka-close lahat ng boundary. Okay? When we say isolated system naman, is a system in which neither mass nor energy cross the boundaries, and it is not influenced by the surroundings. From its term, from its word, from itself na word na isolated, ibig sabihin, isolated, nakaseparate, doon lang sa walang tao or malayo, ganun. Okay? Then next we have non-flow process. Is a process that takes place in a closed system. Example, compressor. Okay, so non-flow process. Sa compressor, example sa compressor. That's a process takes place in a closed system. So closed kasi yung compressor natin. Okay? We also have steady flow process. Is a process that takes place in an open system in which the quantity of matter within the system is constant. Example, imagine turbine. Okay, turbina. Okay, for non-flow work is the work in a non-flow process. So the formula for this one is the integration of your pressure derivative then derivative of your volume. The limitation is from 1 to 2, or that is equal to pressure times the volume sub 2 minus volume sub 1. Steady flow process naman is the work in a steady flow process. Again, steady flow process is the process that takes place in an open system in which the quantity of matter within the system is constant. Okay? Remember, which the quantity of matter within the system is constant. Okay? So, steady flow process, W sub S is equal to negative of integration of 1 to, volume naman dito. Volume, derivative of pressure, the limitation is from 1 to 2, or is equal to volume times quantity of pressure sub 1 minus pressure sub 2 minus pressure sub 2. Then we have law of conservation of mass. Mass, M1, entering the system is equal to the sum of the stored mass, change in M, and the mass, M2, that leaves the system. Okay? That is equal to M1 is equal to M2 plus change in M. Or change in M is equal to M1 minus M2. Then in steady flow system, change in M or change in mass is equal to 0. That's why, because rather, M1 is equal to M2. Whereas, the formula for M or mass is equal to area, cross-sectional area times velocity times the density. So, the cross-sectional area, formula for cross-sectional area is pi d squared over 4. Okay? So, just do dimensional analysis. Okay? Ang matitira na lang dito, uh, maka-mass flow rate or meter cube per second, ganyan. Okay? Na unit. Heat and entropy. We have heat is a form of energy associated with the kinetic random motion of large number of molecules. And under this heat, we have sensible heat. Is the heat needed to change the temperature of the body without changing its phase? Or Q sensible is equal to MC change in T. Whereas Q is the sensible heat, M is the mass, change in T is the change in temperature when C. Whereas C is the specific heat. Okay? Example, specific heat of water is 1.0 calorie per gram meter to then change in or equal to 1.0 BTU per pound degree Fahrenheit or is equal to 4.186 kilojoule per kilogram Kelvin. Whereas latent heat is the heat needed by the body to change its phase without changing its temperature. Latent heat of fusion, we have solid to liquid. Latent heat of vaporization, we have liquid to gas. Okay? Example, melting of ice at 0 degrees Celsius. Whereas heat in latent heat is equal to positive negative mass times the latent heat or fusion or vaporization. Positive if heat entering substance melts. Negative if heat leaving substance freezes. Note, latent heat of fusion of ice or LF is equal to 144 BTU per pound or equal to 334 kilojoule per kilogram is equal to 80 calorie per gram meter. Okay? So these numbers or these are constant. Latent heat of vaporization of boiling water, we have LB is 970 BTU per LB is equal to 2257 kilojoule per kilogram or equal to 540 calorie per gram meter. Okay, remember this value. Okay, all of these specific heat, then this latent heat of fusion of ice and vaporization of boiling water. Whereas entropy is the measure of the randomness of the molecules of a substance. Okay, randomness. And it denotes S. Ano ang sign nitong entropy is S. Okay, S. While ang heat naman is Q. Okay? S na malaki, S is entropy. S. Okay, we have enthalpy or H naman ang denotes H rather. Okay, H is the heat energy transferred to a substance at a constant pressure process. Okay, constant pressure process. We have internal energy. Is the energy stored within the body. It is the sum of the kinetic energy of all H constituent particles plus the sum of all the potential energy of interaction among these particles. Internal energy is itong U. Itong H na ito, that is your enthalpy plus PV or work. Okay? PV mo is work. Okay? Pressure times volume. Next. Okay? First law of thermodynamics, law of conservation of energy. Okay, first law of thermodynamics, to make it simple, kung anong pumasok equals kung ano ang lumabas. First law of thermodynamics principle is energy cannot be created nor be destroyed. It can only be transformed from form to another form. Okay? Sum energy entering is equal to sum of energy leaving. Okay? Kung anong pumasok is equal to yung nilang lalabas. Okay? Or, in mathematical sentence, look at it. This diagram, okay? This diagram or this system. Pumasok ang potential energy 1, kinetic energy 1, at saka H1 or enthalpy. Tapos, na-applyan ng heat, may pumasok na heat. Then, anong lalabas? Pag merong heat, we have work. Then, lahat ng pumasok na potential energy, kinetic energy, at saka enthalpy na final or sub 2. Okay? So, that is first law of thermodynamics. Then, second law of thermodynamics, we have here, heat cannot be transferred from cold body to a hot body without an input of work. Okay? So, this is second law of thermodynamics. It similarly states that heat cannot be converted 100% into work. Siyempre, may losses yan. Okay? The bottom line is that an engine must operate between a hot and a cold reservoir. Also indicated is that energy has different levels of potential to do work, and that energy cannot naturally move from realm of lower potential to a realm of higher potential. We have Clausius statement applied to the heat pump. It is impossible to construct a heat pump that operates without an input work. Okay? Then we have Kelvin-Planck statement applied to heat engine. In connection with second law of thermodynamics, it is impossible to construct a heat engine which operates in a cycle and receives a given amount of heat from a high temperature body and does an equal amount of work. Okay? There must be losses. Okay? Then third law of thermodynamics, we have the total entropy of a pure substance approaches zero as the absolute thermodynamic temperature approaches zero. Okay? Note, the third body is usually a thermometer. Next, we have zeroth law of thermodynamics. Okay? Zeroth law of thermodynamics, when any two bodies are in thermal equilibrium with the third body, they are in thermal equilibrium with each other. That's the concept of zeroth law of thermodynamics. Then we have ideal gas of perfect gas law. Perfect gas is a theoretically ideal gas which strictly follows Boyle's law and Charles' law of gases. Probably you have already encountered this formula in your high school physics or in your chemistry. The equation of state of an ideal gas, we have PV is equal to MRT or PV is equal to nRT. Before, you can be an engineer, memorize mo lang ito na formula. Okay? Bakit? PV is equal to work. So, pwede mong hanap ng work is equal to MRT. Okay? Whereas, P is equal to pressure, volume, pero that is in absolute pressure. R is a gas constant, which is equal to ang gas constant mo, nandito. The value of universal gas constants, 8.314 joule per mole Kelvin, or 1545 feet per pound force mole per degree Rankine, or is equal to 0.82 ligem atmosphere mole Kelvin. Liter atmosphere per mole Kelvin. Finding the value of the gas constant given the universal gas constant, we have, okay, series example, R for oxygen equals to negative R bar over MWCO2 is equivalent to 8.314 joule per mole Kelvin, 32 kilogram mole. That is equal to, the gas constant is 0.268 joule per kilogram Kelvin. Okay? The gas constant of air is 53.34 pound per foot-pound per pound force and pound mass Rankine, or 0.287 kilojoule per kilogram Kelvin. Okay? Remember these values. We have relation between specific heat in volume, pressure, specific heat in volume, your K and your R. Okay, Cp minus Cv is equal to your R. Whereas R is your gas constant, K is specific ratio, Cv is specific heat at constant volume, specific heat at constant pressure ang Cp. Cv is equal to R over K minus 1. Cp over Cv is that is your specific ratio. Cp is equal to Kr over K1. Okay? Boyle's law, in a confined gas, if the absolute temperature is held constant, the volume is inversely proportional to the absolute pressure. So your formula, okay? So your relation in Boyle's law is P1 is equal to P1V1 is equal to P2V2. Okay? Then Charles' law, in a confined gas, if the absolute pressure is held constant, the volume is directly proportional to the absolute temperature. So your relation to the volume and temperature is V1 over T1 is equal to V2 over T2. In a confined gas, if the volume is held constant, the absolute pressure is directly proportional to the absolute pressure. Or kapag given naman ang pressure and temperature, your relationship in Charles' law is P1 over T1 is equal to P2 over T2. And general gas law, combined Charles and Boyle's law, each one of these laws states how one quantity varies with another if the third quantity remains unchanged. But if the three quantities change simultaneously, it is necessary to combine these laws in order to determine the final condition of the gas. We have P1V1 over T1 is equal to P2V2 over T2. Okay? The next is your Dalton's law of partial pressure. Okay? The pressure exerted in a vessel by mixture of gases equal to the sum of pressure that each separate gas would exert if alone occupy the whole volume of the vessel. So, pressure mo is P1 plus P2 plus so on. Okay? That's your Avogadro's number. At equal volume at the same temperature and pressure condition, the gas contain the same number of molecules. So, M1 na maliit over M2, M1 and M2 are masses. M1 na malaki and M2 na malaki are molecular weights. Whereas R1 and R2 are gas constants. Okay? So, these are the formulas. Ratio and proportion lang. The internal energy, enthalpy, and entropy of an ideal gas, we have change in internal energy is equal to mass times your specific heat in constant volume times change in temperature. Whereas your change in enthalpy is, pag change in enthalpy, ibig sabihin, constant pressure process. Pag change in internal energy, constant volume process. That's why, ang change in enthalpy is Cp, or specific heat, at constant pressure change times change in temperature. Whereas S, change in S, or change in entropy is equal to mass times specific heat, Ln, dun ka mag-base sa temperature 2 divided by temperature 1. Okay? No more problem. We have thermodynamic processes. Okay, thermodynamic processes will be discussed next meeting. That would be all. Thank you for today.